So we had, as per our curriculum, we have we have almost completed everything, but there was this part, georeferencing, left. So you can call it like the last day for track one, sorry, module one. And today we'll do our hands-on exercise on understanding how to georeference. So
Mm,
what actually georeference means and how we do it. So
mhm,
the basics to the practical use of georeferencing. And
mm,
then from tomorrow onwards, we're gonna move to module two,
okay.
right? So first of all, uh, now if I have to understand it from very basics, if I tell you this is a house where someone lives, now do you know where this house is? Or like, do you know anything about its location other than the information that it is a house? Do you know anything about it?
No,
No, right? So
okay.
assigning it a reference to understand its location. For example, I say that, uh, give me an example. Where are you living
In Chennai,
in Chennai? So you have like street names or do you have sectors?
street names.
Okay. So, for example, I tell you this is maybe you can call our colony. This house is in our colony. So now you know that our colony in Chennai.
Mm,
So now you have an understanding in which part of the city it might be, right?
mm,
What if I
yes.
give you a pin code? Then if you have a pin code, then also your location will narrow down.
Mm,
So if I give you a house number, so now you know very exactly this is where this house is. So by definition, by definition, to georeference means the act of assigning locations to atoms of information.
mm,
So what it meant is adding something special reference to anything that also helps us understand its location.
mhm,
So that is called as georeferencing. So uh, and the important part because we are talking about GIS, so that locations must be linked to Earth's surface. It should not be on Moon on Mars, right?
mm,
So georeference can have many types. So it can be based on some origin on map and then you mark it by measuring its length from it, from its distance from it, or it can be based on orders like uh, just the type we discussed, street address. It does not have any metrics added to it, any distance added to it, but it is just based on the order that we have defined, that this is a particular colony, this is a particular street. So it could also be based by order.
mhm,
Okay. And then there are nominal. For example, you if I have to say India Gate in Delhi, so you know where it is, right?
Yeah.
So such things. So it is not, it is like so nominal that it is not defined by address. You know about it. So
Yeah.
if I have to say, like I open a shop and someone asks where it is, and I tell it is near
Mm,
India Gate. I won't be even telling the address. I'm just saying it is near India Gate. So such are the ways to georeference. But this term is generally used in GIS for the understanding that if I, for example, uh, I give you a map
okay.
which has some houses, which has a park maybe. There's like which has some road, but it has no information defined on it about its location. Now, just
Loading in progress.
now when you just view this without, if you know this place, then maybe you know, okay, this is that city or something. But if you don't know that city, can you figure out where it is? No, right?
No. Mm,
So assigning it coordinates,
mm,
giving these corners values where it
mm,
actually belong on the real ground on earth, where
mm,
these actually belong,
yes.
giving it a location. So in GIS, we use this terminology as in maps, giving it a location is called as georeferencing.
Mm,
So you were earlier provided with a map that does not have locations on it, and now I placed it, I used the software and I gave it locations on Earth, and now I have location reference to this. Now, georeferencing systems, as we understand, it could be like place names near India Gate, or it could be your postal address that narrows down your locations, or it can be something like cadastral locations. When you have, when you're working with cadastals, it has like um khasra number. Do you know that?
no.
Have you worked with cadastals?
No, I'm just hearing the word first time.
Okay. So the like before we did not have computers. So there were people who would keep the land records. So in old times, this so there are some revenue of people who have these
Mm,
land records, and the maps look like this. So
okay.
they are in this, they are defined by boxes, or it can be in any particular form, but it is generally like this only, and the boxes are defined with a number. So
Okay. Okay.
the land parcel is divided into numbers. So that is called as this cadastus.
Mm-hmm.
So it can also be linear referencing system, maybe something that you define. Linear referencing system means like to say that go 10 meters from here to forward and 10 meters then
Mm,
left. So
mm,
now you also know latitude and longitude. If I give you lat and long, you know the locations, right?
correct. Correct.
Then we have projections and coordinate system. Then we have the
Mm,
GPS system. So
yeah.
these all kind of help you to understand the location. location.
Mm-hmm. Mm. Yeah, I have a question. Like nowadays, we have due to technology, we are able to draw a map and using lat longs and all. A few like 100 years back, also we will be having this type of map, right?
Yeah.
For revenue kind of map. Those times, how this has been calculated, the areas, those things, the maps and all.
So previously, what happened was like the concept of lat long is just recent, like until
After
we,
GPS.
yeah. So what happened before was uh, everyone had their, like, we have called the latitude longitude standards now, but before
Mm,
that, everyone was creating kind of their own reference system to understand.
mm, mm,
So someone's reference system was very similar to lat long. They would call it something else, but it was very similar to that. But it was the accuracy was not so much. And
mm,
in general, what was happening was when you create a cadastral map, you
mm,
work at a very regional level. For example, I work for a village. In a
mm,
village, I do field survey, and
mm,
by the scale on the ground, I
mm.
create a map that is actually very accurate according to ground.
Okay.
I do survey that this house starts here and this house ends here, and I make a representation of it on the map, and I define the scale of it on the map also. That 1 centimeter on the map will means 10 meter on the ground.
Mm, mm,
So the
okay.
accuracy with which that was done on a regional level was very high.
Mm,
So we have for every villages, every cities, we have cadastral maps. So those cadastral maps are now being geo-referenced on our lat long.
mm, mm.
Earlier there was no lat long concept. Those maps have been taken and now put into our lat longs.
Okay.
Now you can using lat long you can find a location on that old historic map because of
Mm,
like now the technology has enabled us,
mm, mm.
right? This is more exactly like how cadastrals look. If
Mm,
you maybe want to check out, you can, there are for every state there is this Bhunaksha.
okay.
I'm just trying to show you an example of how cadastral maps look. Just a moment. For example, if I take, I'm living in Ludhiana, and there are these old times tes tehsil, like which in Ludhiana, where does my village fall? If, for example, it
Mm,
is in Khanna, I choose maybe Baupur. So,
mm.
not,
What does mean by Texel?
huh?
What does mean by Texel? Texel, Kanna.
No, no, tehsil is like the court.
Oh,
From district, there are like four divisions in the district. Each has its own small court.
okay.
So this is here, but it's not opening. I don't know why.
Mm.
So it looks something. I'm unable to find an example, but yeah. So maybe just on Google I can see Punjab cadastral. Click images. So this is kind of the old records. This looks like this, the land parcel here. So you do not have any lat long defined, but because of our latest technology, we are able to keep it and fit it into that map.
Mm.
And yeah, so like for they don't have lat long uh, previously, but now we have placed them such now that we can get their values. But you can see in this map there is no understanding of lat long.
Mm.
So now today we are going to do this exercise. So there is two kinds of georeferencing when you talk about it in GIS. One is that you have been given a map which already has a latitude, longitude, and you need
Mm.
to place it uh, on your GIS system in your software QGIS. So we will be doing the two examples. One example
Mm.
being this one. Now let's you open this link. I'll send you the link. So when you open the link, there is the get the data.
Mm.
In this get the data, select this Southern India image. So it will open. You need to save the image to your PC. Now, then you go to your QGIS. Now, in your QGIS, select a new project. Now, here in your QGIS, under the option layer, there is this georeferencer.
Mm.
So this is an interface where which is we are going to use to do the georeferencing. So maybe just for your reference, first you just go to your on the left on the XYZ, just
mm,
double click OpenStreetMap. And now, yeah, now go to that layer and georeferencer. In georeferencer, file, open raster, add this image here. Able to do it here till here?
yeah, one, two.
So once you open, you see that you can view the map. You can zoom in with your uh, middle scroll, and if you click the middle mouse button, it can also pan and zoom. So in this, this is a British India era map. So
Mm,
they had their own latitude longitude system at that time.
yeah, I have opened it. Mm,
You have opened it.
yes.
Now, what you see here is, so here this thing refers to the longitude and this here refers to the latitude.
Mm,
Now we have to kind of how to explain this part? Yeah. Now because we are going to georeference this and based on the reference on the ground. But the georeference system used here, the geographic coordinate system used here is not the common one we are using because it is of a time when there was uh, not much geographic coordinate systems defined. So at
mm,
that time, they used this geographic coordinate system, which is called as this one. Sorry, this one. So I will explain, but what you need to do is you need to go to this settings button here. This
okay.
that is
Yeah.
transformational setting
Mm,
here. Here in this, you choose these. You choose polynomial to
mm,
nearest neighbor here. Compression type LZW. Now, I think for in your PC, it would be saying invalid projection, right?
it is showing WGS84.
Yeah. So that is showing by default, but it is not, but we are not going to use that one. What we are going to do is we are going to click here to change the system, the geographic coordinate system. We will choose 4042. We will write here in filter 4042. Now we go to this and we write here 4042.
Mm,
So this is defined by the British in 1830s.
okay,
A reference geographic coordinate system defined by them, which was based upon the Everest. Like its location is based on Everest.
okay.
So you click OK.
Mm, yeah.
You check these to save GCP points, load in QGIS when done.
That is grayed out here.
Oh,
Okay, it is below. Okay, JC, GCP. Yes.
Yeah, you need to check these both.
mm,
And then you press OK. Now, what has happened? Like this has transformed into the new coordinate system now. Before
mm,
it was WGS84 for you. Now,
mm.
when you select any point on this, it will be marked according to the British era reference system.
Okay.
Um, Now, there is this, for example, if there is a point here and I also know that point on the map, so I will try to match this point to the point on the ground.
Mm,
So this point is called as ground control point. So in georeferencing, we need ground control points to kind of put or place our map on the earth.
mm.
So in this one, what I see here is this is longitude, this is latitude. Now there is this just adjacent to this settings, there is this add point. This is to add ground control points. When
Okay.
you go here and click this and come here, so it will ask you latitude and longitude. And
Mm.
now it is using this reference system. So you put the value accordingly. Here you can see,
I clicked on it. That is okay. I
huh?
need to put the exact point.
Yeah, you need to put this exact point, this. I think there is some error. This point is not stabilizing. This is- Ah, yeah. So this is happening because, so when you click here,
Mm,
just when you click here, do not zoom or in zoom. When you click here, it will ask you for lat
mm,
long. Now you know the value for longitude is 70, and you know for latitude is 15. You know from here, right? When you go up, it is written 70, and you go check here, it is 15. Now you
mm,
press OK. Now this point is logged. Similarly,
okay.
you know the value here, it is 70 and 10. So
Mm,
you choose 70, 10. So as many as you see here, you can put, but at least 6. So for
mm.
this, I will put 75. So this is 75 and 5. So you see that I've marked at least 6 points. So were you able to mark?
Yeah, yeah, 85 and 15, and then what else? Any direction we can write, right? Uh, like, is there any uh, order that we have to put it, or
No, no,
any
it can
point?
be any direction. You just need to be sure of the lat long. That's it.
Okay. Yeah, I have marked it down. 6 places.
Okay. Just a moment. Yeah. So after you mark this,
Mm,
because these are like the ground control points. So you have marked them the location, what their location is on the earth, based on
mm,
the reference created by the British at that time, right?
mm,
So now when you press this start georeferencing button,
okay,
it will georeference it.
mm,
And when you minimize it, so it has been added to your other map. Now, because the coordinate system here is different, just go here and select the same one, 4042, and press apply. Now this is more accurate. So
mm. Okay,
this
where
is,
did we?
uh,
Okay, like CRS, we can change the same thing, right? 11830. Okay,
mm,
okay.
so what I said was like for that time you when you are giving the ground control points, you give it accordingly to 4042. Now for this base map to the base map behind it, just to
Mm,
visualize, I'm changing that base map's CRS to 4042.
okay.
Yeah. So now you can see you have georeferenced your map.
Mm, oh, yeah.
Now you can visualize it like how clear it is on the.
Mm,
So this is basically called as georeferencing. Now
mm,
there is another part to it. Uh,
mm.
for example, I do a new project. I discard this one. You can save this one for your own reference. I'm just discarding. So now we'll do,
Like how to save this one? Like I don't have the pencil button. Uh,
just go to
to save.
project and save as.
Okay.
Yeah. Why do I still have these points? Okay. Yeah. Now, what are we gonna do is, do you have Google Earth in your laptop?
Ah, yes.
Now I want you to open your Google Earth.
Mm,
Screen
Your
sharing
screen.
has stopped.
Uh,
It was the okay. So, for example, just go to your hometown where you live, and I'll go to Chandigarh. Chandigarh. So, just look for a very good mark. So, if like this part of the city, I can
mm,
see the corners. I can so just look for a very good view where you are able to visualize the corners well, or maybe the so there are like when you place it on the map here, when you place it on the map here, so I will be using these corners. So I am able to visualize these corners very well. So kind of look for an image in your city where you are able to visualize it very well. Now what I'm gonna do is I'm gonna select this area and then save image. Well, save the image.
Give me a minute.
Pardon?
Yeah, give me a minute. I'm not able to use through mouse pad with this laptop
Okay.
and getting mixed in.
Okay, okay. Take your time.
We need the sharp area, correct? Okay.
Pardon?
We need the sharp area to mark, correct?
Yeah, like here I can see the corners and I know these corners in this. I can see the corners here, right? So
Mm.
look for some area that you know in your city where you can mark it on the ground also.
It not it's not necessary to be a very large area, but it can be
Yeah, yeah.
any. Oh, let's start then. I think I don't have like such type of area near my place. So
So what you can do is just go to your Google Earth,
mm,
just follow the same, just click on search Chandigarh. So when you search Chandigarh, this will show you like this, the city. In that city, zoom to the very top left corner of the city, this part. Let me know when you're done. So were you able to locate Chandigarh?
I yes, but not on the sector like you have shown. I'm
Now,
on.
when you click this, are you in this view already? Hello.
Which place is that? Chandigarh. Okay. Mm, yeah,
So you
but it,
zoom into this top left corner of the city, this area.
it's taking me to some field greenery type of, not in the city. Searching Chandigarh.
Not searching the city.
Mm, no issues then. I have some areas near, not exactly the same, but kind of streets.
Okay. So what you do is you just there is in your computer there is this thing called as snipping tool.
Mm,
You just search for it. You just click it
mm,
and click new. Just kind of take a image of it.
okay.
Now for that image goes to in your pictures in your screenshot. It is here. Done till here.
Mm, yeah.
Yeah. So now I will go to QGIS. I will go to layer. I will go to georeferencer, file, open raster, and I will go to that screenshot that I just took. I will open it. Now I have this image here, but I have no locational reference to it. Now I know where it is on the ground. So I know this area.
Hmm.
So this is that area on the ground. Close this. Computer has a shit. So here you can see is
1 minute. I have take this screenshot and just taking it somewhere. I misplaced it.
uh,
Okay.
so uh, now
Yeah. I
what I would
placed
do
it.
is I would go to this.
Before that, do we need to change this thing, the polynomial to
No, for this one, you can just leave it. Yeah, I would change this to just using here 3857. So here I will change it to I'll change this to 3857. This one. And click OK. Mm. Now I'm gonna georeference it same according to my base map. So now I see here this corner.
the
When I
base map also we have to change, correct? To
no no
3857.
I chose it according to the base map only this time. So it is 3857.
No.
This one 3857.
This is Google Earth, correct?
Yeah, this is true color. So now when I look for one of the point that I know, I click here, I click this, and then I click here. Change this also. Change this to the one that we're going to use. So now because I am choosing it from the ground, I don't know the latitude and longitude as such.
Which area, any corner you have clicked in, is it?
I've clicked in this corner because I know
Oh,
where this is on the ground, right?
okay.
Mm. So click here. I choose 857. Now I go to map compass canvas. Now I know that that point was exactly this point. So I'll click here. Now it has itself picked up the XY and I click OK. Similarly, now I know this point here. I click here. I choose it from the map. Now know that that point is this point. I click here. And now I press OK.
Can you give me a minute? I'll
Yeah.
do it. Okay, you just do. I'll follow it later. Because from Map Canva, I'm not able to find out the exact place.
Okay. So for this to accurately happen, will at least the more number of points you select, the more accurate your georeferencing will be.
Mm, mm, mm.
So maybe now I'll take this point. So I've taken 6 points. Mhm. So when I georeference, I start georeferencing. What actually has happened is the image touching.
Coordination.
No, the image touching was not so good. I will maybe try to change it to linear and press OK and then do it. Yeah. So there is this way of doing georeferencing. If you select
Mm,
more and more points, you move to polynomial. But if you are
Mm,
working in very with very less points, then you
mm,
choose linear. So now you can see.
mm.
So
So you already placed a six. No, so this is not enough to go with polynomial.
no. Uh, that is something else. Like linear polynomial is for linear you can just do it even with 2 points also.
Mm,
But more the number of points, more the accuracy. But this polynomial thing is like this is based on the mathematics of how this image is placed on the ground. So
mm,
because these points have xy, they kind of
mm,
act as a solution to a polynomial equation.
mm, mm.
If you know in maths, so like we have now xy that is at least three pair of solutions. That is uh, like the equation would be x raised to power 3 something to this is to understand how the maths behind the image processing. So there are other methods also in this. Uh, Polynomial one, two, three. So more the number of uh, ground control points, it is advised to go and select the bigger polynomial equation. So
Mhm.
there is something called as spline. In that case, you need to have at least 10 ground control points.
Okay,
It will work only when you have 10 ground control points. So
okay.
these are mathematical ways to present the image on the surface.
For linear, how many points at least we need?
For linear, you can even like just I think even with the 2 points because linear equation is like x plus y is equal to 3. So it is just you need x and y. So yeah, so uh, linear even works with one solution that is 1 point x and y. If you have even one value, it will
Uh-huh.
place the map on the ground, but it will not be accurate.
Okay.
The direction will not be accurate. Just to, for example, I explain you it in mathematics. So if you just choose 1 point x and y,
Mm,
x and y. So there can be my writing is so bad. Now there can be a line passing it through like this. There can be a line passing it through like this. So the direction of the image will not be right if you make a linear, though it is possible with 1 point, but it is for you that it will give you an error. So maybe the image should be uh, the image may should look like this, but
mm.
because we just give it 1 point, it may look like the direction is not constant and it may look in this direction. But that 1 point that you choose will be right because you just chose one answer to the linear solution. But in XY also, if you at least choose two, because then what happens is if you at least choose 2 points for a line to be defined, now it cannot change direction. It
Mm.
is fixed that it has to pass through it. So
Correct.
even though linear can work with 1 point, but it at least needs to have 2 points.
Mm-hmm. Okay. So polynomial,
Huh?
it's minimum how many points we require?
Okay. So just like in
Minimum three.
eh,
Okay.
just just like in this,
It
there
needs to
was
be joint.
huh?
Yeah,
Pardon?
I think the polygon should be joined. Minimum 3 points.
So let's Google it. Just happened here. Mm. Yeah. So minimum number of GCPs for different polynomial equations. So there is, as you can see here, there is an order of polynomial. This is first
Mm,
order polynomial. This is second order polynomial. This is third order polynomial. So depending on the formula, this formula, it is a mathematical evaluation. I don't know how it is like.
mm,
So based on this, if you have like a first order polynomial, so you need minimum three.
mm,
But just like in linear, you need minimum one. But for at least to be error free, you need two. So
mm,
similarly, for first order, to be error free, you need four.
mm.
Similarly, for second order, you need six, but to be error free, you need seven or more. And
Okay.
similarly, for third order, you need at least 10. And
Okay.
to
But
be error
in our
free,
case, we already had 6 things, correct?
yeah.
But still, it was the first time it gave an error. Like,
So the error that was because, this image is big image.
mhm,
And I just took the points in the center of it. So also your point distribution matters. So if I have
okay.
to work on a polynomial equation, I need
Mm,
to take it like one
the
point
extent.
here, one
Okay.
point here, one point here,
Far away. Okay.
one point here, one point here, one point here. Whereas in linear, that will not matter that much.
Mm,
But in polynomial, I also have to think about the distribution of the GCPs. They should be evenly distributed.
mm,
So now what happened was because my points were just here and
mm,
the system did not understand how to evaluate this area.
mm,
It evaluated this area, but it got confused about how to evaluate this left out area. So it came to a result that was not suitable to us.
mm,
So maybe what we can do is uh, let us give it more points. Uh, So I have points from good part of the images, but to locate a point on this
Mhm.
would really take some more time for me. But
Mm-mm.
maybe we can try to use the uh, polynomial one here, resampling. Yes, never is okay. So let's, so now you see
Mm. Okay.
this was the previous one. This is what I georeference now.
Okay.
This time the polynomial one is more accurate.
Mm.
So it kind of wants a good distribution of your points all over your imagery. Maybe if you want to share your screen or you want to try one, maybe try a link.
Yeah, yeah, I have tried it a month back. I was through 4 or 5 points.
Okay,
I was able to get this.
okay. So, okay, you do one thing is it's kind of like a assignment for you or homework if you have the time, but it's not like compulsory if you have the time. Just look for your home location and
Hmm.
try to capture an image of it in Google Earth.
Okay.
Just try to find a location where you think like I showed you that these points I know on
Mm-hmm.
the Google Earth on the base map. So just
Okay.
kind of
Yeah,
try
exercise I'll
to,
do.
yeah,
Mm.
just make sure whenever you work, everywhere the coordinate system should be common in the
Base map
georeference
and
and
okay.
in this tool when you make the point and also here in this place. So
Okay.
at these three places, it needs to be the same. So let me
Mm.
check how it varies in polynomial 2.
Mm.
Now this point is not so accurate in polynomial 1, whereas it is coming more accurate in polynomial 2. It has stretched the image more
Mm.
accurately than polynomial 1.
Okay.
We can also see it in polynomial 3.
Which one looks good? Is it one or two?
2 is much better. Maybe
Okay.
let's try 3. So you can see the results in 3 are even better. So this point should have been here.
Mm.
So, sorry, should have been, no. Now, for our particular case, I think the best values are resulting in polynomial 2.
Mm.
So when I'm moving back to polynomial 3, I'm getting more distortion. So
Okay.
if I want even much better result in polynomial 3 than in polynomial 2, so I need to make more points. I need to then look for more points around the city.
Mm.
Then
Mm.
I will be able to make the correct use of polynomial 3.
Okay.
So as we go higher up in the series, after polynomial 3 comes
Mm.
spline transformation. So we kind of need as many points to make it fit particularly on the ground.
Oh, okay. Why it is necessary? Like spine is giving more accurate than polynomial since we already have the mm, more than 6 points, right? And in spine, we'll be having more points to add that, right?
So these are more like of how to this is more like kind of a mathematical transformations. So people, the scientists who created these transformations, now
Mm,
they came up with basic transformation, more complex transformation. So as you, for example, you have a image and you
mm,
have maybe you have kind of 100 ground control points. So
okay.
you need to be more accurate on the ground. So
Mm,
and to be more accurate on the ground so that your
okay.
point exactly shows the location on the ground. So it will
Mm,
stretch the image accordingly. It will transform the image accordingly. So that is why it is called transformation. So
mm,
I showed you in an example that the line is being transformed. When we have 2 points in linear, the line is fixed. The transformation is as such. So similarly, a polygon works for a image that the
mm,
transformation is fixed. Uh,
mm,
if you are getting more and more points, so the transformation is kind of getting more restricted. Then,
mm,
and that restriction leads to either accuracy or it is a point beyond accuracy. It moves to distortion. So when it is moving to distortion, it means that we need more points to reach accurate to come back to accuracy. In case it is less than accurate, like good accuracy, then by adding some points we can by that means like you can just add 1 or 2 points or delete 1 or 2 points, but you are at a good accuracy.
mm.
So the mathematical part of it, I don't think we need to have to have an understanding about it, but it is like if you have a background in mathematics, you can just for your own studying mathematical.
No, no, I just wanted to, in real time, where we'll be using this 100 type of, I mean, if we have more than 6 points
So for
in
example,
real
if
time.
it would be like if you have a drone imagery,
Mm,
maybe I gave you a drone imagery and the
okay.
image does not have a spatial reference, so it was more like the image like this one
Mm,
before. So you have to give it a spatial reference. And the
mm,
customer says, I need high accuracy. So
mm,
you
mm.
for high accuracy you need to for every corner you have to evenly distribute your GCPs. For example, if the image is like this big, in that case the number of GCPs will be very high. So just
Okay.
working with linear or polynomial one will not give you accuracy. You have to
Mm,
stretch your image accordingly. To get that transformation, you have to go higher up in the transformation level.
okay.
Yeah. So there are like uh, so you enter more into the math domain if you want to. So there is linear is also called as affine,
Mm,
right? Polynomial, what is a polynomial? There
Mhm.
is spleen, that is, even I don't know the mathematics behind the spline. So
Okay.
it is a non-polynomial method, often called rubber sheeting, that introduced to local deformation to achieve an exact fit at each GCP.
Okay.
So even it is beyond my scope also, like what is the mathematics behind spline? So
Mm-hmm.
there is Helmert, there is projective. So these are the commonly used ones. There can be many, many.
Mm-hmm.
Okay, so what you need to do is just try to look for a location near your house or somewhere you know about, or just try to make kind of this georeferenced image. And
Okay.
yeah,
Yeah,
just
I will
if you
try.
have the time, okay? Maybe if you do it, just share it with me in the next class.
Sure.
Okay, any doubts until today?
No.
Okay, then we'll meet each other tomorrow.
Okay. Fine. Thank you.